So let's talk about grade breakdown in here first, and then we'll dive in and start talking about some, well, let's just, so, and I'll put up the official document uh, later. I've been playing catch up. We had fall break, and then I forgot this class started this week, and all sorts of stuff. But everything we need to know is right up here somewhere. Just have to dig it out. All right, so grades in here. We will have a final exam, and this guy is going to be worth 25%. Okay? 25% final exam. It'll be an in-class exam, last day of class. I don't know if it, well, it definitely won't be a 4-hour exam. It will not be a 4-hour exam. We might work on some stuff for the first 2 hours, and then the exam might be the last 2 hours. Or you might go the other direction, where we might do the exam and then work on some stuff the second 2 hours. That way you're fresh when you take the exam. We'll figure it out when we get closer, but you'll have a final exam worth 25% of your grade. We will have quizzes, and quizzes are going to be worth 10% of your grade. You will have a quiz at the beginning of every class. So every class we will have a short quiz. I'll drop the lowest of these. All right, so what are the quizzes for? The quizzes are to show me, now, if you've had my classes before, I do encourage you to collaborate on homework, right? I don't care. This isn't about cheating or not cheating or something. At the end of the day, my job is to give you a grade based on how well you've mastered the material, right? So if all 4 of you want to work together in your homework, I'm fine with that. I don't care. But I'm going to find out on these quizzes whether you're learning what you need to learn from the homework assignments. Does that make sense? All right, so some of you are going to be stronger programmers in here. Some of you are going to be weaker programmers. Now, stronger programmers can become stronger by helping weaker programmers, and weaker programmers can become stronger by getting a different point of view. So when you're always getting my perspective on things and you see me do stuff and put it together really quickly or something like that, you know, it might be easy to get discouraged. Well, if you're working with a classmate and you see that they sometimes make mistakes or something like that, I mean, I'm still waiting for my first error in programming. I've never had an error in programming. I don't know what it feels like. It's a joke. Man, these guys you're uptight, both of you. It's just like really serious. So, I think a lot of times students who work together, you can help each other quite a bit. So I'd encourage you to do that. But whenever you're working on homework assignments, remember that the goal is not to get the homework done. Well, that's not the goal. Okay, that might be a goal. Okay? The goal is to learn. That's why you're in school. That's why you're taking classes. You know, ultimately, I want to give you a grade that you've earned, but I also want to give you a grade that you deserve. That's indicative of how well you understand the material, so you can go out into the real world and do something with it rather than have this piece of paper that says you know some stuff that you don't. Make sense? So I'm not going to try to catch you cheating. I'll just find out on those quizzes whether or not you're learning as much from the assignments as you should. Okay, so the quizzes are going to be designed to be, I would call it, they should be relatively easy if you learned what you needed to learn from the homework assignment leading into that week. So they'll probably be based on that homework assignment. Make sense? That is to say, if after going through the experience of doing the homework assignment, you would have a pretty good chance of doing it on your own if you had to do it over again, you would probably do final quizzes. All right? So we will have a quiz at the beginning of each class. I will drop the lowest one of those. That way, at the very least, you get to see what the quizzes are like first time. Or if you happen to miss a class. If you happen to miss a class for a legitimate reason that I know about ahead of time, we can talk about counting a quiz double or something like that. But, you know, make sure you leave early enough to come to class. You know, we can't have traffic was bad for 4 weeks in a row. You know, I get it. Sometimes it happens, right? Heck, this morning I was 5 minutes late to my 8 a.m. class because the interstate was like basically closed from Grafton to here. Never happens. I mean, I'm a 6-minute drive from campus. It took me like 40 minutes to get here today. But it happens, right? Can't happen every single day, every single class for a month. All right, so leave early enough. If you're driving from a far distance or something, leave early enough, get here on time. Before I forget, everybody in here should, if you're already on this, then you will know about this already. But we use Slack. How many of you are already on our Slack system? Okay, so from a web page, you'll go to cuwcs.slack.com. Okay, that's going to take you to a page that looks like this. Now, you can use Slack completely online, like this. All right, now, for you, if you've never been on Slack before, you're going to need to create an account. Okay, so go to create an account, and you're going to put in your cuw.edu email address. All right, and then you'll also pick a password. So what Slack is effectively a chat community. So here's my Slack app. So notice we have all these channels. So for all of my classes, we have a channel here. So here's the 537 channel. We'll probably just use the core one here since we haven't used it in a while. So we'll use the 537 channel. This is a public channel. So once you join our Slack program, which once you sign up for an account, you're allowed in. You just have to have that cuw.edu thing. Then you can either use Slack from a web page. So if you don't want to download the app, you don't have to. You can just use them from a web page. Or you can get the app for iPhone. You can get the app for Android. You can get the app for Mac. You can get the app for PC. I would get it for all your different communication devices. I would turn on push notifications on your cell phones for at least the 537 class. That way, when I put announcements or something like up there, maybe extra credit opportunities, stuff like that, you get a push notification letting you know that it's occurred. Okay? So as you can see, for instance, here's some of my other classes. Oh, yeah, here's I'm going to be late this morning. All right, so I messaged the class at 7:52 for an 8:05 class, letting them know that there was a backup. So they would have all gotten push notifications letting them know that there was an issue. Okay, so get on Slack. It's multiple reasons for this, for us in here. A, it's my definitive way of communicating with you. I'll also try to send an email when I can if I have to make an announcement. But I can send an announcement on Slack instantly. Because of the way Blackboard works, I basically have to get to a computer in order to send a mass email out to all the students through Blackboard. All right, Slack is more convenient. It's also probably among the quickest ways of getting help from me. So either Slack or a text message. What's nice about Slack is if you have a question about the homework assignment, maybe it's an understanding question about the homework assignment, like are you asking us to do this or asking us to do something else? Well, you put it into the 537 group in Slack, I can answer it, and all your classmates can also see the answer. It might benefit everybody, all right? Especially having a class that's relatively small like this, use this as collaborative space, right? Ask questions, say, hey, do you want to meet up for coffee and work on homework? Whatever it is, take advantage of this type of thing. Okay, but we do use Slack in the department. Most of your teachers are supposed to use it. I don't know if that many of them do, but most of them are supposed to use it. I use it heavily. So Slack is a good way of getting a hold of me. You can send me a private message. You will never see this channel on yours, and that's a good thing. Things happen in that channel that should not be happening at a Christian university. That is a former student who's kept alive this old private channel. Yeah, it's a thing. All right, so in any case, sign up for Slack, download it for all your devices, and then go ahead and double click on the 537 group so you've joined the class. All right, and then I'll also post code examples in here that from what we work on in class. And I'll also give you a link to stuff. So at the end of class, whatever we've been working on, I'll upload it to GitHub. And then I'll give you a link to it in here. So you have a convenient way of downloading what we've been working on in class. So as you go to work on your homework assignment and you want to kind of compare like, oh, well, what did he do in class? Yeah, you can watch the videos. I record all my lectures and stuff like that, but also you'll have the actual code so you can reference those things. So I'll put all that stuff in Slack so it's easy to get a hold of. Make sense? Okay, so final exam, 25%, quizzes, 10%. That means the rest is homework. So that's 65% is homework assignments. Now, homework assignments are going to come in 2 flavors. There's a guaranteed flavor each week. So we have programming assignments. And then we have writing assignments. All right, now our writing assignments are going to be a little bit different than I maybe have done in the past. Sometimes you'll have a writing assignment that that deals with something with technology, something we've been talking about, similar to if you took the 535 online, you had every week you had a writing assignment, you had a programming assignment. When you take it live, sometimes the programming assignments are bigger in the live classes. So sometimes I'll make the writing assignment and the programming assignment. If the programming assignment is big one week, the writing assignment will be smaller or non-existent. So probably our writing assignments in here will be smaller writing assignments because our programming assignments are going to be of a pretty decent size. All right. So what's the purpose of the writing assignments? Well, several of you, English is not your first language. And I assume several of you would like to get jobs working in the United States, right? Doing something, at least during your OPT years or something like that. Well, your written communication is going to be a very important aspect, if for no other reason than to get you the interview, right? Because that's going to be a major issue. A lot of you know that I work with a lot of the Indian students. I hang out with them, and so I hear about all these stories behind the scenes, and generally speaking, they don't get the time of day from employers, and it's because you sound foreign when you apply for jobs and stuff like that, and it's unfortunate. That's the way it works, but that's the way it works. So the more practice we can get you writing stuff and getting used to writing things in such a way where it doesn't sound like broken English, the better. Okay? Because at the end of the day, what's the goal? It's for you to get a job and keep a job. Right? That's what we want to get to. So we will have writing assignments. They'll come in a couple different forms, and you can wait and see what they're going to look like. But the primary assignments in here are going to be the programming assignments. Right? Now, one thing I highly, highly, highly encourage you to do with the writing assignments, and it will make your grades way better than they would be otherwise, is take these to the Writing Center. All right? Because generally speaking, when I look at assignments written by non-English speakers or non-native English speakers, the content is typically okay. It's the writing style that struggles. So if you write a paper and you have good content in there, and you take it to the Writing Center and they help you turn it into something that looks like a native English speaker wrote it, that's going to benefit you in seeing the difference between your natural writing style and what you probably need to be able to produce when you're applying for jobs and things like that. And it will also benefit you with your grades in here. Make sense? Because typically, content's not the problem. All right? Now, having said that, let me throw one more thing at you. And this has been going on for a while. It's actually quite funny when the faculty get together and talk about it. But we've had quite a bit of issues with plagiarism with papers and stuff like that in the MSIT program. From my perspective, I don't necessarily care. You're only hurting yourself. But it is quite funny. So there's a strategy that a lot of students take. It's I don't know what they're even calling it. It's like the thesaurus strategy, where because we have this safe assign thing, right? That checks your papers to make sure you haven't copied them from someplace else. So students, what they do is they go through and they see what their safe assign score is going to be. And then they go through and they use a thesaurus to change individual words to another word that means the same thing, okay, in the paper to get that safe assign score down. Well, what's really funny is, students don't even cheat very well. It's kind of a funny reality of it. There's this one student, the author of some paper they referenced, It's like, I don't know, Jim Waters or something like that. Well, they use the thesaurus to replace his last name with like Stream or something like that. I mean, they're changing people's names. So I don't know. Sometimes it becomes kind of funny. You know, you're only hurting yourself if you go and you copy somebody else's words to write them down. You find you'll get your grade, but you're going to have problems getting the jobs because you're going to have problems getting the interview to begin with. Nobody's going to give you the time of day. They're not going to find out what you actually do know because you're not going to get past that initial stack of applications, right? Use the writing assignments as a time to practice your writing. There's a means for this stuff. There's a reason for it. So do yourself a favor and write it yourself. Take it to the writing center and let them help you clean it up. And then you can use, you can help yourself or measure yourself each time by saying, okay, each week I take it to the writing center, they're changing less and less, which means that you're probably getting better at sounding like a dumb American, right? That's okay. Okay, you got to play the game, right? Because we all want to get jobs when we're done with this. So, get better at writing it in the way that the potential employers want to see it. All right? So let the Writing Center help you with this. That way, when you turn it into me, I'm not going to be knocking you points because something sounds like broken English. Make sense? Most of you are not going to listen to me when I say this. Every semester, I say the same thing. And every semester, I usually have like one student that does it. Do it. It will help your grade, okay? So everybody heard me say, take your writing assignments to the Writing Center, right? You're going to do okay in the programming assignments. They're going to be hard, but you do okay in those. Those aren't supposed to read like English, right? These are the hard assignments for a lot of the international students. All right, so that's the grade breakdown on the class. We will talk about the final exam as we get closer to it. Each class will have a quiz right at the very beginning. I'll usually have the quizzes graded and posted by probably middle of the day, the next day. That way you have some pretty quick feedback on the quizzes. So you kind of, chances are if you take the quiz, you kind of know whether you probably did all right in it or that didn't go well. You have a decent idea, but I'll try to get feedback on the quizzes up pretty quickly. And then homework I usually have graded sometime during the week before the next class. All right, questions about grades or any of that stuff? All right, like I said, I'll get the official syllabus up either during one of our breaks today or sometime early in the day tomorrow. Okay, so now let's we're going to spend some time talking about, let's go a couple routes here. Why don't we spend some time talking about Android first? So one of the things I like to do in this class is I like to have, I want you to come out of here, with some new knowledge, right? So you're going to learn about some new programming stuff, but also with a practical skill, all right? A skill that, you can use to maybe make some money if you want to sell some apps on the App Store, or B, it helps you pad your resume to make it so you maybe can more easily get a job, that kind of stuff. So we're going to be doing Android application development in here. But we're going to be learning data structures. So we're going to be talking about data structures and we're going to be talking about Android development. Android development is not what you're learning in the class. We're learning data structures in the context of Android development. So our actual programs, instead of being stupid text-based programs that ask you a question, you type it in, and then you press enter, and then it gives you a result back, it's going to be you put something into a text box, you click a button, you're going to be building an interface. All that's changed is you're going to have a dorky graphical user interface instead of a dorky text-based interface. Make sense? But along the lines, you're going to get that skill set in Android development that will help you do something that's, applicable to today's world. Because not that often today are you going to be going into industry and having to write software applications that are text-based. But it actually does still exist. It actually exists specifically in the IT industry. You might be writing software that runs on like a router or a switch that's laying under the floorboard someplace across the building where you have to remote into this machine and write software for that. So, It's not completely unfounded, but it's certainly not as fun. Okay, so let's talk about Android for a little bit. I'm going to take breaks roughly every hour for, well, usually breaks will be about 30 to 45 seconds long. I used to go for like 2 or 2.5 hours, then take a break, and then students didn't like that. They had to start wearing diapers in class, and it was a thing. Yeah, so about every hour we'll take like, a 8-minute break, a 10-minute break, something like that. If you have to get up and go to the restroom between breaks, just get up and go. All right, we're all adults. At the end of breaks, make sure you come back on time. You never know when I might give an extra quiz. Because grad students are notorious for, it's like, yeah, let's take 10 minutes, we're back in 10, and like 27 minutes later, they saunder back in. They went out for a drive or something like that. All right, so come back from the breaks promptly, and so we can keep trucking. All right, so the tool we're going to be using for Android development, go to the website, and I'll put links up to these on the on Blackboard as well. But if you go to developer.google.com, this will take you to Google's developer network. Let me make sure I'm on the right. All right. Now, I'm hoping at some point one of our assignments will do something here with this Firebase. If we don't get to it in here, depending on how the class kind of progresses, it is something worth looking at, because this is a good tool that we'll want to use it at some point. But this is effectively Google's real-time database. Google didn't make it, another company made it. Google acquired it a couple of years ago, and now their whole infrastructure is built on top of it. All right, so if I come down here, I'm going to click on Android down here at the bottom. I think it actually was developer.android.com would have taken you there as well, but let's just see. Yeah, developer.android.com would have got you to the core site. All right, so you'll get here. You want to click on Develop. And then somewhere there should be a Getting Started. Click on Android Studio under Develop. So you'll download Android Studio 2.3.3 if you're on the Mac. It's probably going to be a pretty similar number if you're on a PC. One of the reasons I use Android instead of iOS, I actually prefer iOS development. But from an education perspective, if we do Android, it doesn't matter what kind of computers you have, right? If you have a Mac, you can use Android Studio. If you have a PC, you can do Android Studio. If you have a Linux, you can use Android Studio. So we'll all be on a consistent tool. So download Android Studio 2.3.3. You'll be able to do all your homework assignments on this. And your first assignment will be due next week. So you'll be able to practice with it, and you'll see us using it today. All right, so this is the tool that you're going to use. How many of you have used GitHub before? Okay, 1.5 people. All right, so let me go to GitHub. Let's talk about a couple of these different tools. All right, so github.com. Let's just talk about this first. All right, so really the tool is called Git. All right, and Git is a, really doesn't have to be software, but let's just, software storage with changes, iterative development environment, basically groups of people who are collaborating on a project. They might all work on the same Git repository. Okay, so this works around something called a repository, where a repository is a collection of all the files and every change that has ever occurred on the files, all in one place. All right, that's what GitHub is. Now, for us, well, that's what Git is. Git's the tool. GitHub is a website that is built for Git repositories. All right, there's some other ones. So GitHub is one. There's another one called Bitbucket you maybe have heard of. There's a whole bunch of them. All right, these are all tools that are built around the Git protocol. Typically, Git is used for programmers who are collaborating on a project. That's not how we're going to use it. The way we're going to use it is an easy way for you to share your Android projects with me and for me to share my Android projects with you. So the punchline here is that so with GitHub, we have a local Git repo. So it's our local Git repository. So this is where our Android project and all changes will live on our machines. And then we're going to have our remote Git repo. And for us, this will be on GitHub. So when we're done working for the day, or I want to share some stuff with you, what I'll do is I will commit my local changes to my local repo, then push those changes to the remote repo. And once I've pushed them to the remote repo, then you will have access to that project up on GitHub. So somebody else can go to GitHub, so I'll just show you this as an example. So I'll go ahead and sign into my account here. And so here, I'll just, was this your project, or was the Tipper was yours, right? Yeah. So they were working on a project. This was an Xcode project, but here is their project, their workspace. This is where the code files live. It's an easy way to look at the code online. Similarly, it's also easy to download this. I can download a zip file of this, and now it's a good way of distributing software. How many of you have ever downloaded a program off of GitHub before? Sometimes that's the way that third-party applications are distributed. It's quite common in actuality in the IT industry for folks to, especially when you have an open source project. We've heard of open source before, right? What does open source mean? Yeah, so there's lots of projects that are out there that are open source, right? They're kind of community driven and they have a goal, and there's a whole lot of open source projects in the IT industry, because the people are trying to share a wealth of knowledge. And if you're in the IT industry and you've solved a problem, well, maybe somebody else can benefit from that, because certainly, you're doing a whole lot of Google searching looking for solutions to some of your problems. So you want to share that wealth. So you put this information out there in an open source project. A lot of times it's on GitHub. And here, we'll just click on Explore up here, and we might be able to see some projects that are out here. Let's see, a front-end checklist for modern websites and meticulous developers. So here's this thing called design blocks. That's for people who do bootstrap websites. So whatever, you can flip through this stuff. So if you're interested, if you're writing a website that's based on Bootstrap and you want to take advantage of some of this guy's stuff, you can click on his screenshots and kind of get an idea on what the stuff might look like. Then if you're happy with it, you can go ahead and you can download the project. A lot of times they have a README at the very bottom, and I'll talk about this README here in a few minutes, because a lot of the directions for GitHub talks about the README first, even though we will probably never write a README for anything we have in this class. READMEs are really if you're distributing a project that you want other people to kind of know what it's about and how to use it and stuff like that, where what we're going to be using it for is for you to submit your homework to me, right? So here's my GitHub link to my homework, so I don't just have to have the zip file with 500 pieces of 500 files in it. It also allows me I can get your stuff graded more quickly if it's on GitHub, because then I can grade it from my phone or something like that as well. All right, so this tells you a quick start, how to use it, blah, 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 all sorts of stuff like that to get you up and running on this particular project that's hosted on GitHub. So this would be an example of an open source project. You won't have to do anything like this. This is just kind of showing you how this works at the end of the day. Make sense? Okay. So we'll be using GitHub to share our code with each other. Go ahead. Well, it depends. So when you have a repository like this, GitHub, their business model is they want to sell you on private repositories so people can't see it, but they want people to use it freely. So anytime so we can have as many repositories as we want. They just have to be public, which means that people can see them. But only people who have been invited to collaborate on your project are allowed to commit those changes to your repository. So for instance, I can download your project. I can make all sorts of changes I want locally. I can then even create a brand new GitHub project and push those as tipper update or something like that. But unless I have permission to commit to the tipper repository, I won't be able to push my changes back over your copy. That make sense?
You can submit a new copy in another name.
Yeah, you can submit a new copy under a brand new name. Then it becomes your project. So that's usually called forking. Okay, when you fork a project, that's one of those very unfortunate. Well, I think it's unfortunate and funny technology terms. So the idea of fork has been around for a very, very long time. Now, anybody know related to operating systems? Well, yeah, it's really operating systems. What forking is? Be very careful. I completely enunciate the word, right? What is it? Well, it's related to parallel things. So, so here, this actually gets to a kind of a funny backstory. So I'll kind of explain it to you here. So, in operating systems, we have the fork system call. All right, and what the fork system call does is it creates a duplicate process of the current running process. All right, so you have a program that's running, and now you want to create a second one. Now, two processes, this kind of comes down to how things are scheduled on the processor. So if you have a program running on your computer, and this program's job is to, I don't know, it doesn't matter what it's supposed to do. It's supposed to do something. It's going to get some amount of CPU time. If he forks a copy of himself, now these guys get twice as much CPU time because they each are going to get scheduled on the CPU separately. Now, realistically speaking, these guys now have need to be careful because they need to be able to work in tandem. So if this guy's solving a problem that this guy's relying on, he has to wait for the solution, then this guy isn't all that useful. But if these two guys can split the work up, so for instance, let's say that we are, a good example of multiple processes being very useful is like video conversion. All right, so if you have you can really think about converting a video between one format and another as similar to like raking leaves in a park. So if you have two people raking leaves in a park, they'll be able to rake those leaves more quickly than one person raking leaves, right? Well, because the work can be divided, I can say you do the left half, you do the right half, and I'll sit back and enjoy a cold beverage. Right? Because I'm old. I don't want to rake leaves. Yeah. But we divide it up and it can get done more quickly. Now, when you're raking the left half, that's not impacting the work you're doing on the right half. Correct? Those are divisible things. Video conversion works the same way. You can convert the first half of the movie. You can convert the second half of the movie. Or you can pick the first quarter, second quarter, third quarter, fourth quarter, and get it done 4 times as quick, something like that. All right, so if we're doing that type of thing, forking a child process then helps, because now what we have is we have 2 copies. We have the original copy of the program and we have this new copy of the program. And what ends up happening though is the fork system call actually returns an int. So when we call fork, we'll say int who am I is equal to fork. After that, we're going to have 2 different versions of who am I. One for the original and one for the child. One of these will be 0. And one of these will, I'll just make up a number. This is a process ID. If it's a 0, you're the child. You're the new guy. If it's some value other than 0, that's the process ID of the child that you just spawned off. That means you're the parent. And a lot of times what will happen is then the parent goes and does one thing, rakes the left half of the park. The child then says, oh, well, I'm in charge of the right half of the park. Something like that, okay? So this has to do with, and then our our evolved version of this is called multi-threading. So multi-threading is an upgrade to multiprocessing, because multiprocessing is expensive. When if we create a duplicate of a process, that means that these 2 programs are identical. Everything up to this point, there was one process here, now we create a clone. They're identical, so all the stuff that's already happened, all those variables are already all duplicated. So we've taken twice as much memory to hold 2 things, even if the logic from that point forward doesn't need some of the stuff from up here. Where having multiple threads says that here's the parent process, I'm going to spawn off a couple of worker bees that's underneath me, and they're going to go and do some work for me. So it's kind of more compartmentalized. Along those same lines, multiple threads actually leads to potentially lower performance, because with multiple processes, if you use the fork system call, you can take advantage of the operating system's good nature of scheduling stuff for the CPU. So if you want your program to be a really important program on the computer, and let's say that your program happens to be something that can divide up the work quite a bit, so like the raking leaves problem. If we're in that boat, then what we can do is we can make 10 copies of ourselves, each taking 1/10 of the work. But now we have 10 separate programs that are all working on the same problem. And those 10 separate programs are scheduled on the CPU separately, which means that they'll get 10 times more total CPU time than other individual programs on the computer, because they're a full-fledged process, and processes get scheduled for the CPU. That make sense? Where threads share the parent's CPU time. So if you're a parent process and you spawn off 30 child threads, that means that you're sharing your single allotment of CPU time among your 30 children. Just more of an operating systems type of argument, but that's where the fork system call comes from. And there was actually an interesting conversation I had years ago. We were at I was a Unix system administrator at a previous university, and so this had to be in 2000, 1999, something like that, close to 20 years ago. And so we were at this restaurant, and we were talking about this program we had written that was using this fork system call. So we're sitting at this table, and we're talking about forking children at this table. And then we're talking about which you might understand that could sound strange to somebody else sitting at a nearby table. And we were also talking about reaping, so killing. So we were having to pick up, kill off other processes. So kill off the children, right? And we were just in passing talking about killing children and forking children, And so this old lady comes up to us and was concerned. So we explained to her what the situation was. But it's a fork is an uncomfortable word to use in mixed company, I suppose. But because of where it came from, GitHub, well, it actually came from Git. Git allows you to fork a repository.
So what's the primary reason behind multi-threading and forking? Is it speed or?
Well, division of labor. So it's not always speed, but it's usually speed. Yeah, it comes down to more multitasking. And so maybe the easiest way to answer your question is to give you an example of when it's what would happen if we didn't have it. So let's say, so before we had multitasking on our computers, that's something we take for granted today, right? That, I can have, right now I have my web browser open, and I have Slack open, and I have Eclipse open. I have all these programs open, right? Well, this wasn't a thing before. Okay, and how many of you, I mean, we might be at the point now, actually we probably are. Have any of you ever used computers that didn't have multitasking? What operating system?
I think Windows long back in maybe 92, I think so.
Okay, so like Windows 3.1. Yeah, Windows 3.1 did not have multitasking, that's true. So, but generally speaking, how old were you in 91?
2 years I used to go to play games in my father's
Okay,
computer,
yeah, so,
radio and everything. I'm not sure.
so it was an older computer even then.
Oh yeah.
Yeah,
Radio
yeah, now I got you. I remember when Windows 3.1 hit the shelves. It was an exciting day. I remember when DOS 2 came out. I'm so old. It's terrible. Oh, it is terrible. But anyways, so before we had multitasking, you might have a situation where, so how does multitasking work? So multitasking has a lot of different requirements. It requires that your operating system knows how to share time between multiple processes. So assuming we had a computer that could do that. Let's say we're using a video converter. So we already established that video conversion is something where you can divide the labor up. If we didn't have the ability to break that up into multiple processes for that, if you had a really, really, really fast computer, let's say it's today when we think about our processors, they're all multi-core processors, right? So we have 2 or 4 cores in our computers. The new processors are now 6 cores for general purpose. I know that AMD has had the octa-cores for a while, but 4 cores is good enough for this example. So when we say a processor has 4 cores, what does that ultimately mean? Yeah, at the end of the day, it can do 4 things simultaneously. Okay, if your computer only has 1 core, what does that mean? You do one thing at a time. It can do one thing at a time. Now, because computers are really, really, really fast, did we not have multitasking until we had before we had dual core processors? Or did multitasking exist way before we had dual core processors?
We had, but it best perform. It divides the CPU time between different tasks.
Right, but so the short answer is we had multitasking before we had multiple core CPUs. So how did that work? So I'm telling you that in a single core CPU, we can only actually do one thing at a time. It's only possible to do one thing at a time. Yet, I'm telling you that multiple processing existed before that. Windows 95, let's call that our first multitasking operating system. Yeah, it's faking us out. Okay, we're the jokesters here, right? So the idea is that CPU is like a Ferrari, so really, really, really fast at doing tasks. Okay, and humans we're relatively slow. So if it can do 5 tasks in the amount of time where we believe 5 things are happening independently of each other, even though they're actually one thing's only happening at any single moment in time, just the way CPUs handle time is different than our time, right? We don't notice the difference between a half a second and a third of a second. Those are the same amount of time to us, right? And we take it to the extreme with the CPU. The CPUs today are doing billions of instructions per second. Billions. That's a lot. Okay, that's a lot. So they're so fast that it's faked us out, because if a bunch of stuff happens within a 1 second period of time, that's just as good as 5 things happening within a short period of time, right? We're faked out. So even if we go back to a single core type situation, from our perspective, if we have a task that could be divided up, if we don't have the tool to actually divide it up, then we don't have the ability to do that. So for instance, we go back to this leaf raking example. If we have a whole park that we need to rake the leaves in, and we decide we're going to split it up among the 5 of us, we're going to get it done much quicker than if only one person did it, right? But that's because we've innately decided that we have the ability to fork multiple processes, okay? That we can split ourselves into 5 worker units. What if we didn't have that? We're all standing here, but we actually don't have the ability to do that. We know that this problem would support it, but instead, you got to do all the work. I didn't make the rules. The far left, you're the lead process. That's all right. So he's got to do all the work because he wasn't able to spawn off child processes to help. That makes sense? So, some problems lend themselves to multitasking, but we didn't have the tools to accomplish it. But even before we had, the really nice thing with multiple cores, things do get more complicated for now scheduling for these multiple cores, because if you have 4 different CPUs to schedule for, now you got to decide, well, which one's least busy right now. Do you think that's a really difficult thing? Maybe on the surface, and your first guess might be, oh yeah, it sounds like it's pretty hard to have to schedule for 4 cores. Well, it's all because we're using high geeky speech, right? If you walk into McDonald's and there's 4 registers that are currently open during the lunch rush, which register do you go to? The one with the shortest line. You just did quad core process scheduling. Right? So you go to the shortest line. Now it is a little bit more complex than that, because sometimes you might need to make sure that if 2 processes are related to each other, it might be important that one doesn't get CPU time till the other one does. So you might have to be a little bit like, let's say that I'm paying for the order, but you're doing the order. Well, I need to make sure that she gets in line first, right? So she can place the whole order before I'm there to pay for it. I should be the next person in line so I can actually do the pay for it part of it. As opposed to me there, I'm ready to pay for something, but the thing I'm paying for hasn't been placed yet. Makes sense? So now the order of operation makes sense. So splitting multiple processes, is really about, does allow us to have certain problems get more CPU time when it would be beneficial, but at a cost. So in general, I would say modern computer science folks would say that multi-threading is better than multiple processes. So when you would fork a process, when you get two separate processes, that's dangerous, because now these are 2 individually floating entities in the operating system that can run amok. Now, and they're each getting their own amount of CPU time. So if we say a single process gets 2 seconds on the CPU, just throwing a number out there. If I make a duplicate with fork, now I get 4 seconds on the CPU dedicated to my problem. If each of those guys fork, now I have 8, so on and so forth, right? Right. So you can start taking over the CPU by having a program on there that maybe runs an infinite while loop or something like that, and just keeps making children of itself. And you can take over you can crash an operating system actually pretty quickly. In fact, the quickest way to crash it is you run out of most operating systems. So I mentioned back here, we're talking about hacking at this point. Back here, this is the process ID of the child. So depending on how old the operating system is, maybe you can have 65,536 unique programs running on a computer at once. 65,536 process IDs. Make sense? Well, that's not that huge of a number, is it? So what if you have a single program spawn off 65,536 children? Each one gets a process ID. So on one hand, you might say, well, maybe they're not doing very much. The CPU can handle it, but what's the real downside to having one program that creates 65,536 child processes, even if they're not taking up that much CPU time as individuals? Well, it is performance, but why? The operating system can only have 65,536 unique process IDs. And we've taken up all of those unique process IDs with that one process who spawned off 65,536 children. What does that mean when the user double clicks on their next program? Can't open. Out of process IDs. So you've brought an operating system to its knees just by taking up all the names of all the potential children, even if your processes don't do anything. That's like 5 lines of code. You can bring an entire operating system down. Not good. So they have some protections in there. Typically, a single program that's not running as the super user is limited to the number of child processes it can create, so that it can't completely take over an operating system. Well, a term for which? Creating a whole bunch of... There probably is. I mean, it's an attack on the system's resources. So I don't know if there's like a fancy modern name for it, like some kind of, like, I don't know if there's like a rapper name for it, but there might be. I mean, along the lines, it's similar to like a denial of service attack for network attacks, where you hit a web server so many times that it can no longer pick up the phone, right? The phone is ringing, as they say, ringing off the hook. It's not able to answer the next incoming connection because you've bombarded it with 4 trillion incoming connections. This is the same thing, except you're doing it from the inside, which is actually worse because things happen more quickly. So an operating system can be, and this is where it gets interesting. So we're getting way off topic, but it's still fun, I guess. This happened to me when I was a Unix system administrator. So imagine that you had an attack like this that took over all the process IDs in the system. How do you fix it? How?
In Windows, we got a task manager in the process.
Can't open task manager. You're out of process IDs. Okay? Even in Unix. So what would we do? I mean, usually our Unix servers, you don't have necessarily monitors hooked up to them. You would remote into them. So you would make an incoming connection to the telnet daemon, or the SSH daemon, whatever you were going to use, and they would try to spawn off a new terminal for you. No process ID. You couldn't connect to the machine. So now you have this issue where, especially in a production type environment, and this is really, now we're talking about IT type stuff, so you get more than what you paid for, I guess. You have a production machine that maybe it's in the middle of a backup. There's some processes that were already created. So they're getting CPU time right now, okay? We can't create any new ones, but existing ones are still running. And let's say that you're in a situation where they need to finish running, that if the system went down right now, it would be bad. Let's just assume that's the case. A, you can't monitor the computer because you can't start a new process, so you can't look at what's currently running on the system. You can't look at Task Manager or anything like that unless you already had it launched. So you don't know what the progress is. It's a guess, right? The only way you can really fix it is to turn the machine off and then turn it back on, rebooting the operating system, right? And then you might have to roll back to a previous backup or something like that, the last known good state. When things, because stuff may have been, like, let's say you're in the middle of a backup or in the middle of a restore. Things might be corrupt in the middle there. Yeah, it's the world of kind of hacking and stuff is is a pretty interesting one, and it's in many cases it's kind of sadly shocking how trivial the attacks are, like how vulnerable we are, right? I mean, if somebody gets access to your computer, how easy can they get rid of all your data? Yeah, if you walked out of the room right now and somebody sat down in front of your computer and it hadn't gone into the sleep mode where they had to type a password in or something like that, couldn't they just go in and delete all your files in 10, 15 seconds? And no problem. Well, same thing's true, except servers are targets. Now you can remote into the thing, and if you can figure out the password or hack your way into it somehow and get to what's called root access. How many of you have heard in the world, so we'll twist this back towards Android. Have you ever heard, how many of you are Android users? How many of you are iPhone users? 4 iPhone users. See, I don't know if you know this yet.
Oh, yeah.
This is
Professor Wall actually said it in class.
yeah. Yeah, this is.
Today marks a really good turning point in your life.
We do still have an iPhone 8 now. So I do development for both iPhone and Android, but I've been an iPhone user since day one, you know, and yeah, they just ticked me off this last. I mean, as somebody who's always had the newest iPhone, I always get the newest one. I don't feel like I mean, even right now, I can't pre-order the iPhone 10. You can't pre-order it until 2 a.m. on Friday, overnight on Thursday. That's when the pre-order date is for it. My wife already has her iPhone 8, but the iPhone 10, the new device, the good one, right? You can't even pre-order yet. I shouldn't have to wait 2 months to pre-order the device, and they're going to make 5 of them. So they're going to be sold out forever. Really, it would be the correct economical thing to do would be to buy 2 of them and just sell them. Because you could probably make 3 times what it's worth on the device just because somebody wants it day one and isn't going to be able to get it until the next year, something like that. But I decided, so I jumped over to Galaxy Note 8. I like iPhone better probably, but this has a lot of cool stuff on it, and I can do my VR stuff with Gear VR. So if they both came out the same day, if I could have already had an iPhone 10, I would have probably gotten the iPhone 10. But it didn't seem right to have to wait 2 months for the good thing. Like, why would they even? I had a 7 Plus. Yeah. No, I get a new phone every year. You got to have a new phone, otherwise, I mean, before that, so my iPhone's 6S Plus, the one I had before that, I use that as a soap dish in my shower. I mean, you might as well use it for something, right? And which iPhone do you have? You have a 6? So I have a newer phone than you use every single day, and I use it to hold my soap. I don't actually, but it is a funny, a funny thing. Yeah, I don't know. I need to have the newest technology. I can't have these old phones.
Yeah, I have 7 Plus, and I wanted to have the next iteration. There's no point to have 8 if you spend extra. I think 115 to get the 10.
Well, the question is, when are you going to get the 10?
Right.
That's the bigger question. But you're right. Although now after the fact, and this is really a problem with Apple, a poor marketing scheme, because the iPhone 8 sold very poorly. I mean, their naming conventions messed up to begin with. Like, you have the iPhone 8, and they also released the iPhone 10. What are they going to do next year? What they should have done is it should have been the 8, the 8 Plus, and the 8 Pro. They should have called the feature one the 8 Pro. Because really what they did this year that was a kind of a cool thing is they released a phone that they weren't trying to hit a price point. If you look at iPhones over the last decade, each year they came out with a new phone, people have always complained, well, why doesn't it have this? Samsung does. Why doesn't it have this? HTC does. Well, it's because Apple's always had a price point. When they take one product, they move it here, they slide the next product into the exact same price point. The price of the phones do not change. So they're saying this is what we can put into this experience for $699. Make sense? Well, with a Pro line, if they're going to say, here's the iPhone 8 Pro, we're going to say, look, this is everything. This is all the stuff that we can shove into this, and you're going to pay what it costs. But here's your other options. You can do the normal ones. Here's the expensive one. If you want this and you're willing to pay for it, here it is. I think it's a cool thing. And then they had to go and screw it up with a naming convention. It's going to be embarrassing next year to see like how they try to backtrack on that. But who knows? But we still have an iPhone 8 in the house. But what I was getting at here is it's very interesting actually that most people, including myself, when you watch the keynote where they announced the iPhone 8 and also the iPhone X, the 10, the 8 looked like was an incremental upgrade to the 7, right? Not a big deal. The processor on the 8s, which is the same processor that's on the 10. So they share the same CPU. The upgraded A chip is extremely impressive. It's by far the best mobile processor out there today. Historically, what we've looked at over the last 3 or 4 years, the difference between iPhone and the Android competitors. So if we just keep it simple, Apple has their own chips, these A chips that they bought a CPU company years ago. They say it's their own silicon, but there was some other company making these chips and they bought it. Now they're Apple chips. So they were making chips. And then kind of the competitor on the Android side is this chip called the Snapdragon. It's the Snapdragon chip. Now so like this guy is a Snapdragon 835. It's an 8-core processor. This is like probably the best Android processor. The Pixel 2 has the same processor in it. So any like new top tier Android phone is going to have that same top tier processor in it. Well, what we've seen over the last several years is Apple, their processors win every single race dealing with single core performance. How fast can you perform one task, the sprint? All right, so because even though previously Apple processors had 4 cores, 2 of them were high performance, 2 of them were like task oriented, slower performance cores. Well, if you took one of their high performance cores and compared it to one of the cores on this guy, the Apple guy would beat it handily. It would be like Usain Bolt versus me in a race. All right, so the iPhone was very, very good at single task. But this guy, based on what we've been talking about today, dividing labor up, because he can do 8 things at once, was really, really, really strong at multitasking. So that was your trade-off, right? So sometimes this guy was way faster, certain applications. Sometimes the iPhone was way faster, certain applications. The new chip on the iPhone 8 wins both races, handily. It didn't just like catch up to this guy. It blew past this guy in multi-core. So the new processor is quite impressive, actually. To make the iPhone 8, I would say substantially more than an incremental upgrade if you actually look what's under the hood. The phone itself seems like it's the same phone. My wife got the iPhone 8, and from her perspective, nothing's changed. Just because it's capable of doing something faster doesn't mean you're going to recognize that in reality. Once we start getting a lot of this AR kit, augmented reality stuff out, things might change, but whatever. Okay, so interesting. So we took a half-hour detour into forking. Yeah, I know. Just that we could learn so much stuff, right? Just a wealth of knowledge up here. I'm telling you, I'm getting old. Keep forgetting stuff. The other day, I forgot my name. That ever happened to you? Yeah, my real name. I was getting ready to sign. I was signing something. I couldn't even get started. Like, who am I? I mean, I came up with it pretty quick, but there was a hiccup. There was a hiccup there, right? I didn't get my name right. All right. So, in any case, GitHub is going to be the way we distribute our software. Android Studio is going to be the tool we use for writing our software. So when you download Android Studio, there is an initial kind of setup time. So I'll go ahead and open up Android Studio here. And notice you can check out a project from version control. So version control would be an example of that would be GitHub. Now I'm going to go ahead. I'm going to see I'm going to do check for update. I'll force it. So updates. There's an update to the SDK. So Android emulator, Google repository, version 58. So a couple things to look at here. For those of you who have laptops or PCs at home, do any of you have AMD chips, or are they all Intel? Intel? Okay, we won't have a problem. A very important part of what we'll be doing in here is with this thing called HAXM, H-A-X-M. One of the big weaknesses of Android development historically was this problem where the emulator we would launch would take like somewhere between an hour and a month to launch. It just took forever to launch the Android emulator, and it was really, really, really slow, so it made it difficult to test your applications. To the point where it was better to go ahead and just plug your phone in and test it with your phone. Now, ultimately, before you release an application, you probably want to test it on a real phone. That makes sense. But one of the nice things on iOS is, you could write an iPhone program. You don't have to own an iPhone, or you at least didn't have to plug it in or any of that stuff. You just run it on the emulator, and the emulator was great. Or the iPhone simulator, rather, was great. It was always really, really, really slow on Android. This HAXM thing fixed that. Made things way, way, way better, blah, blah, blah. So in any case, you'll want to configure that. So when you first download it, it's going to probably have the checkbox already checked as the default, but make sure you have HAXM installed. So you want to spend some time going through the setup process for Android Studio, because there is you'll download it initially. It's like 400 megabytes. You're not done yet. Okay, it's like a 1.5 gig total download, something like that. So do it before you go to bed some night. Just let it cook overnight, downloading all the crap. All right. I'm a little scared to download this right now, so I'm going to actually tell it to remind me later for this guy. All right, so let's go ahead and let's take an 8-minute break. I'll get this guy uploaded to YouTube, and then we'll come back. We'll start looking at the basics of Android Studio. Sound good? So come back at 7:25.